Hi, welcome back. A warm welcome to you. So we have started coordinate geometry by plotting points. So after that we found the formula to find out the distance between 2 points. Now let's try to find out the coordinates of a point which divides a line segment in a ratio. Let's just say that there are 2 points. Let me just try to draw a straight line. This is a straight line or line segment. I have 2 points. I can say A and B, P and Q, whatever it is. Let's say it's A and B, and we are trying to find out the coordinates of a point P which divides AB in a ratio. Let's take that ratio as L is to M. So I say now we are going to work on finding out the coordinates of this point. We know the coordinates of A and B. They are nothing but A is x1 comma y1 and B is x2 comma y2. A is x1 comma y1 and B is x2 comma y2. Let us say the coordinates of P as x comma y, which we are going to find out now. So I'll just say x comma y. This is what we are going to find in couple of minutes. Okay. Now how we want to proceed from here? We know 2 points. We have to find out a point which divides the line segment, that means the line joining these 2 points in a specific ratio. So what we know about points, we know little bit about slope, and we know that slope is nothing but equal to vertical distance by horizontal distance. And we also know that the slope of this line should be constant. So let's first try to plot horizontal distance and vertical distances and see from there how we can proceed. Okay, let me plot the horizontal distance. The horizontal distance between A and P, if I draw perpendiculars from P to A and also from B, if I drop these perpendiculars and I join them, okay, right? Now let's see what is the horizontal distance between A and P. What is the horizontal distance between A and P? P x coordinate is x, A x coordinate is x1, and we are going in this direction, positive direction, right? So x is greater than x1, so this will be x minus x1. Similarly, what will be this? x2 minus x, because x2 is greater than x. So this is what I found. Similarly, let me do it in the vertical direction also. Let's plot it in the vertical direction also. This point coordinate, y coordinate is y2, and this is nothing but x comma y. Okay, so I have another point here, but I know the y coordinate is always y because it's a straight line and it's actually horizontal line, to be precise. So what is this? y2 minus y. Let me also do it for this one, for P, and for P what is the distance? y1, y minus y1, y minus y1. Let's also try to name these perpendicular points also. A, P, B, let me say this is equal to C, and this is equal to D, and this is equal to E. Okay, makes sense? AB is our line, P is the point for which you want to find out the coordinates. What we did? We just tried to find out the horizontal vertical distance of each point. For A, the horizontal distance is between them, right? For AP, the horizontal distance is x minus x1, vertical distance is y minus y1. Similarly, between P and B, horizontal distance between P and B is PE, that's nothing but x2 minus x. Similarly, the vertical distance between PB is nothing but B and E, that's y2 minus y1. Now, we have been given that P divides AB in the ratio of L is to M. That's already given to us. Okay. Now let's do one thing. If we observe this diagram very carefully, let's try to see whether we have any similar triangles in here. Now see, AD and PE are parallel lines, so I can say the corresponding angles are equal. That means this angle is equal to this angle, and these are 90 degrees, both of them, because they are perpendiculars. We drawn perpendiculars. Automatically these angles are also equal because sum of angles of a triangle is 180 degrees. See, we have two similar triangles. No, it's not completely similar triangles. We have only angles, but we also have to say that the sides are also in the proportion. For that, we'll be using law of proportionality. Let me just take couple of minutes to just recap. You should be aware of this, but I just want you to remember this, get this back. Okay, let's say there is a triangle A comma B comma C, and if you are drawing a line parallel to BC, let us say this is equal to DE. The law of proportionality says that if you are drawing a line parallel to any side of the triangle, that line will divide the remaining two sides in same proportion. We have been already given here L and M. We have been already given here, and this side is in the ratio of L is to M. If this is parallel line to this, then this also should be L is to M. That means now for these two triangles, I have angles are equal and also their lengths are in proportion of L is to M, right? I think that makes it pretty clear. Now that will enable us to straightforward go ahead and equate the sides of, compare the sides of two similar triangles. What we are saying, these two triangles are similar triangles. What are those triangles? Triangle APC, comma triangle PBE. I should give them in the same way, right? This angle should be this angle. My right angle also should be in the same position. It is here at the end, so it should be at end. So it's a PBE. This is very important. Whenever you are specifying the name of the triangles, you should match the angles, right? Sometimes it can be reflected also. Right? You have to be very careful. These two triangles are similar. So can I say like this? These two triangles are similar. Now let's go ahead and try to compare and see. Seems to be interesting. We seems to be reaching some conclusion. So let's not waste time. Let's go ahead. Okay, now let's take x coordinate. First I want to find out the x coordinate. That's nothing but x. I want to find out the P x coordinate. So I will compare horizontal distances. What is in these two triangles, what are the horizontal distances? X minus x1 and x2 minus x. But we know when we have proved these two triangles are similar, we have known that these two are in the ratio of L is to M. Automatically x minus x1 and also x2 minus x should be in the ratio of L is to M, because that's what law of proportionality says. Now do the cross multiplication. If I do the cross multiplication, L into x2 minus x is equal to M into x minus x1. Let's try to bring all x to one place so that we can divide by something and get the value of x. So this simplify, Lx2 minus Lx is equal to mx minus mx1, right? If I take x that side, this becomes Lx plus mx is equal to Lx2 plus mx1, which is nothing but, if I take common here x, this becomes x into L plus 1. So I can say x is equal to Lx2 plus mx1 divided by L plus m. This is the x coordinate. This is the x coordinate. What is that we have found? Let me just write it down here so that it's very clear. What's the x coordinate we have found? By that is x is equal to Lx2 plus mx1 by L plus m. Okay, right? Now similarly, can you go ahead and find out the y coordinate? I will leave it to you. I'll just give you how you have to compare them, then you can take it forward from there. Let me just erase this and give that to you. Now this changes, right? Instead of x2 minus this whole thing, now I have to take y, right? Now what are the y, what are the vertical distances? For this triangle, vertical distance is this, that's nothing but y minus y1 by, what is the vertical distance here? y2 minus y, you can compare it to L by m, and you will see that you will get in the similar fashion y equal to L y2 plus m y1 by L plus m. If you compare this, you can go ahead and do that. I'll just give you the coordinate. You can go ahead and do that. It will simplify to this point. Y equal to L y2 plus m y1 by L plus m. So just to summarize what we have done, we have been given 2 points with the coordinates x1, y1 and x2, y2, which we have been asked to find out the coordinates of a point P which divides AB in the ratio of L is to m. So we started with assuming that these values are of coordinates of P are x, y. Then what we did is we found the horizontal distance and vertical distances. We found out that these two triangles APC and PBE are similar to each other. You can use another approach also if you are interested. You can try that way also, you will get the same answer. You can take triangle APC and also triangle ABD. That is this small one and the big one. That way also if you do, they are also similar to each other. So that way also you will get the same answer. What we did then? We know that these two triangles are similar, so their sides should be in the same proportion. The horizontal distance of this triangle and this triangle should be same. Similarly, this side and this side should be same. Hypotenuse also should be same. By equating them, we got the coordinates x, y. Now this division is called as internally. This is called internal division because why? The point is between the 2 points for which you have to find out. Now let's take the another case where the point is external. Okay, right. I think you have noted down this. The x coordinate is Lx2 plus mx1 by L plus m. Similarly, y coordinate is Ly2 plus my1 by L plus m. Okay. Now let's do the same problem if it is a external division. What's the meaning of external division is, suppose these are the points A and B. Now the point P which is dividing is external to AB. right? Now suppose this is dividing A and B in the ratio of L is to M, then this is L, and starting from here this is equal to M. Let me just erase that so that it's clear. What I mean to say, PA equal to L, PB is M, because it's external division. So what's the meaning of externally means? The point for which we want to find out the coordinate, earlier it's internal, it's in between A and B. Now it is not between A and B, it is external to A. That means from here it's dividing A comma B in the ratio L is to M. Now let's take this case, it's similar, but I just want to go through that so we are clear. Okay, and we know the coordinates, so let's start. Okay, we know the coordinates of A. Like earlier example, it's x1 comma y1. Similarly, B is x2 comma y2, and P we have taken as x comma y. So let's also take here also as x comma y. Let's do the same thing. Let's try to plot horizontal. Let's try to draw perpendiculars and get the similar triangles. Now what triangles are similar? Let me say this is equal to C, and this is D, and this is E. Now the triangles P, this is A, sorry if it's not visible. So the triangles PAC is similar to triangle ABD. We have proven that, right? Those two triangles are similar earlier, because we know the angles are equal, and it has been given that these are divided in the ratio L is to M. So by law of proportionality, remaining sides also should be in the ratio of L is to M. That's how we got them as similar. Now let's try to compare the sides of these two triangles PAC, that means PA to AB, PC to AD, and AC to BD. Let me write a straight simple equation. So it says L by M, no, is it M? See here, L by M minus L, right? We are comparing PA and AB. L by M minus L equal to this distance. Okay, let me write this distance so that it's clear to you. What is this distance? Horizontal distance. What is this distance? What is this distance? This is x1, this is x. So this becomes x1 minus x. Similarly, x2 and x1. This is x2 minus x1. Similarly, if I go vertical direction, this is y1 and this is y. That means this is y1 minus y. Similarly, this is y2 and this is y1. So this is nothing but equal to y2 minus y1. Are you with me? We just only tried to find out the horizontal distances between them. Now I can compare these two triangles, right? I am trying to compare PA by AB, or let me write that step also so that it's pretty clear to you. This is what we should have done in the last, when we are doing internal segment also, but I think you are pretty clear with it. But anyway, I'll write that one step for you. We are trying to say PA divided by AB is equal to PC divided by AD, that's nothing but equal to CE. AD, PA divided by AB is equal to PC divided by AE is equal to, what is that? You have to go this way, right? DE divided by DB. You are comparing these two triangles, this to this, horizontal to horizontal, vertical to vertical. I can say AC or I can say DE, doesn't matter. PA by AB is equal to PC by PA by AB is equal to PC by AD equal to AC by BD or DB, whatever it is, doesn't make, right? Okay. Now let's try to find out this. PA, what is PA? We know PA is equal to in the ratio of PA by AB is in the ratio of L by M minus L is equal to PC, that's x1 minus x divided by AD, nothing but x2 minus x1 is equal to AC. AC is this vertical distance, y1 minus y divided by y2 minus y1. Now we will calculate the x coordinate automatically. Based on that you can do the y coordinate. I will do it for x, you can do it for y, but we will be using this equation. Let me start and do that. Okay, I am taking this part, I am taking only this part. You can go ahead and do this, equating with this to find out the y coordinate. Okay, now what is this? If I cross multiply, L into x2 minus x1 is equal to M minus L into x1 minus x, that's nothing but equal to Lx2 minus Lx1 equal to, let me multiply this, M into x1 minus L into x1, right? M into x1 minus L into x1 minus of M minus L into x. You can see I am just retaining this as it is because I am interested in calculating the value of what? Calculating the x. So I don't want to simplify this. I can cancel Lx1 and Lx1. Okay. Then what happens? I can say that if I take mx1 that side, this becomes Lx2 minus mx1. Are you with me? I am just taking mx1 that side, so this becomes Lx2 minus mx1 divided by minus of m minus L is nothing but L minus m. This is my x coordinate. Maybe if you feel like I have skipped a step, I can write it here. Lx2 minus mx1 is equal to minus of m minus L is L minus m into x. So you want to know x, divide both the sides by L minus m. This is what you will get. Lx2 minus mx1 by L minus 1. Now can you find out the relation between the internal and external division in the formula? It's pretty simple. When you are doing internally, it's Lx2 plus mx1 by L plus 1. When you are doing it externally, Lx2 minus mx1 by L minus m. That's a simple difference between them. Okay. Now let's go ahead and try to do couple of sums using this concept, whatever we have learned. Let's take a simple example here. Find out the coordinates of the point. Find the coordinates of the point which divides 5, 1, 2, 7 in the ratio, I will say internally. This is very important. You have to see very clearly internally, externally. Otherwise, you will get it wrong. In the ratio 2:1. Internally in the ratio 2:1. Substitute in our formula. Straightforward. We did all the hard work. We know how to get it. So x equal to Lx2 plus mx1 by L plus m. Y equal to Ly2 plus my1 by L plus m. Okay. Now you are comfortable putting this? That's fine. x1 y1, x2 y2, L and m. I prefer 2. So I'll go ahead and say x equal to L, nothing but 2 into x2, 2 plus m is 1 into x1, 5 divided by L plus m, 2 plus 1, 3. Similarly, my y equal to L is 2 into y2 7 plus m is 1 into y1 1 divided by 2 plus 1. I'll write it for you. That's 3. So this simplifies. 2 2s are 4 plus 1 5 is 5 divided by 3 x y equal to 2 into 7 14 plus 1 divided by 3. This simplifies to 9 by 3 equal to 3. This simplifies to 15 by 3 equal to 5. That's nothing but, so the coordinates of the point are nothing but 3 comma 5. Are you with me? We just applied the concept. So what we have been asked? There are points 5 comma 1. Actually it's not as per the graph, so just only for our understanding, it's actually in the reverse. In the ratio 2:1, this is the point. This point is what is dividing. This is P, this is A, and this is B. Let's go ahead and do another example. I'm trying to give you one example where I can club couple of concepts. Okay, let me go ahead. Can I clear? Sure, thanks. So let us say if x comma 1, 2 comma y are divided, that's D, internally in the ratio of 2:1 by 0.3 comma 5, find out values of x comma y. Pause the video and try if you can do this. See here, I have x1 y1 x2 y2. I have L is to m, and also I have x comma y, because my variables are now not in the points. Earlier what we did, we know this, we know this, we know this, we have been asked this. Now this is another way of asking. I have been asked here x coordinate, I have been asked here y coordinate, but I have been given furnished with remaining all details. So just pause and try this. I will be doing it. You can come back and have a look at it. Okay. So I know my formula for x is equal to Lx2 plus mx1 by L plus m, and x is already given as, this is x3, this is L, this is m, this is x2, y2, x1, y1. 3 into 3 is equal to, I want to say 3 is given is equal to L, that is 2 into x2, so 2 into 2 plus m is nothing but 1 into x1, that's nothing but x, we have to find out that, divided by L plus 1 m, that's 2 plus 1. So this simplifies to 3 equal to x plus 4 by 3. That gives me x plus 4 equal to 9, which simplifies to x equal to 5. That's the x part. Now let's look at the y coordinate. To get the y coordinate, I will be applying the formula y equal to Ly2 plus my1 by L plus m. I know y is equal to 5, so I will say 5 is equal to L is 2, y2 is y, I don't know that, I have to find out. plus m is 1 into y1 is 1 divided by L plus m, that's nothing but 2 plus 1. So this says 5 equal to 2 into y is 2y, 2y plus 1, 2y plus 1 divided by 3. This simplifies to 15 is equal to 2y plus 1, right? If I cross multiply, 2y plus 1 into 1 equal to 5 into 3, 15. This gives me 2y equal to 14, which says that y equal to 7. So the value of x is 5, value of x is 5 and the value of y is 7. So this is nothing but 5 comma 1, 2 comma 7 are divided in the ratio 2 is to 1 by 3, 5. You want to cross check this, what you can do is take 5 comma 1, 2 comma 7 and apply the formula for 2 is to 1 and see whether you get 3 comma 5 or not. You can do that. You can do that. I'll just check it for you. See here. L into x2, 2 into 2, 4 plus 1 into x. This is only the thing we don't know, right? X is 5. 4 plus 5, 9. 9 by 3 is 3. Similarly here, 2 into y, 7. 14 plus 1, 15 by 3, 5. So we are good to go. So next video, we will see how to find out the midpoint of a line, and also we will also know about medians and how to find out a centroid of a triangle. I will leave you now. Thanks for watching. Bye for now.